Hello, today we are going to talk about human variation in a very specific sense. We are going to look at three problems with the concept of race. Now, reviewing a little bit about the biological concept of race, when we are using the term race, we are referring to a subspecies of a specific group. So when we use the term race, we are saying specifically within Homo sapiens that there are subspecies of Homo sapiens. Now, as you have watched in the film Race, The Power of an Illusion, as you have read in our open educational resource textbook chapters, that there are very much ethnocentric social constructions of race that continue to this day. Let me give you a little bit of a history lesson, specifically within anthropology and the biological beginnings of the social concept of race. We start to see hierarchical classifications of race beginning in the Western world around the 16th century. We see that Johann Blumenbach, looking at terms related to geographical distribution, such as Caucasian, Ethiopian, Mongolian, Malaysian, or Malay. Now, all of these particular terms correspond to a geographical location. And Blumenbach identified a degeneration of geographical populations. And it starts with Caucasians. He believed that Caucasians descended within the Caucasus region of Europe and that they were the very first peoples. And every population that came about, whether Ethiopian, Mongolian, anything away from this special Caucasus region was essentially a degeneration of the original population. We're looking at the 18th century with Carlos Linnaeus. His name's familiar to you because he primarily identified the binomial nomenclature of taxonomic classification that we still use today in the science world. He identified various populations by skin color or skin tone. This is where we get white, black, red, yellow. Not so much of a hierarchical connotation there, but nevertheless issuing color, skin color specifically to populations. Now, Linnaeus and Blumenbach essentially establishes this basis for a race hierarchy. And when we're looking at race specifically, Linnaeus, Blumenbach, and others really focused on what we call biological determinism, which is a particular phenomenon that's governed by biological factors. It's biology that determines our outcome. And this is very different from what we believe to be true today. It's not so much biology, but also culture. We have anthropologists that fought against this racial hierarchy idea. Primarily Franz Boas, he academically fought against this in his book, Race and Progress in 1909. And he also publicly, throughout his career, fought against this idea of racial hierarchy and biological determinism. His protege, Ashley Montagu, also wrote a book, Man's Most Dangerous Myth, The Fallacy of Race, in 1942, and also publicly spoke against this. Anthropology and other social sciences have been at the forefront of fighting against this concept of biological determinism, where we can identify race within our biology. Now, I'm going to get into 3 problems with race as a measurable value. Now, if you're coming into this lecture cold without reading our textbook chapters or um, watching our film, Race, The Power of an Illusion, this is going to be a little bit, I don't want to say shocking, but different from the social construction of race. So, if at any point you have questions or you're a little bit confused about where I'm going with this very focused lecture, go ahead and refer to our textbook or even spend 55 minutes and watch that film that we have on our lesson for this week. All right, here's the first one. The first problem with race as a measurable value. Now, remember, in biology, we are measuring things, and we've been measuring things such as traits, such as traits that are inherited since week 3, week 4. And so, the very first problem that we have with race as a measurable value is that race is arbitrary. What defines race or this concept we call race? And who decides? So, are we measuring race through skin color, through blood type, through skull features? We know studying DNA, we know studying the cell, we know studying heredity, specifically looking at Mendelian genetics, that we have to identify a measurable trait, and that most traits found within many species, especially humans, are independently inherited. So, for example, when we are looking at independent inheritance of traits, uh, can an individual only be born with green eyes and blonde hair? Is there any other combination that is possible other than green eyes and blonde hair? Yes, you could have green eyes and brown hair. You can have green eyes and red hair. So we are looking at in the principle that Mendelian uh, gives us, which is inherited characteristics. Characteristics are inherited independently of one another. So when we are looking at um, race, how are we going to measure that? Let me give you an example. Let's say I am the person who decides how race is measured, and we are going to measure race by blood type. And you can see our little blood type chart here. We have dominant, recessive, and codominant blood types. Let's just say, forget skin color. We are going to create a new concept of race that's totally measurable by blood type. Now, if you know your blood type, I know my blood type, I'm type B, so I am going to be the type B race. If your blood type's type B, you're with me. If you're not, maybe you're type A, B, O, whatever the case may be, we are going to forget about race using our knowledge of race within the United States, which is white, black, Asian, etc. Forget about that. We're going to measure race using blood type. Oh, well, okay. You don't want to do that. Well, what about skull features? The point is, you have to pick. It's totally arbitrary. What are we going to use today? What are we going to use tomorrow? What has it always been? And the real question is, can it change? And who would decide that? So that's one problem with race as a measurable value. Totally arbitrary. The second one, again, this is what Mendel gives us. We are looking at populations are genetically open. No group has exclusive possession of any particular variant of any gene or genes. And the example we just used, blood type. There's no geographical population that only has blood type A or B or AB or O. We're also looking at this with skin color as well. We have no exclusive geographical population or type of human that has an exclusive skin color. Again, we are looking at the law of independent assortment. Traits are inherited independently of one another. And the third problem with race as a measurable value, we see that differences within a population are generally greater than differences among populations. So if we take any two populations, let's say they're separated geographically. We take a population on the continent of Asia, we take a population on the continent of Europe, and we look at them independently. So looking at Asian genes versus looking at European genes. And obviously this is a very, very broad example because we have so many ethnic populations and we have so many languages and we have so many countries, but this is just an example. So we are looking at the population of Asian population and a European population geographically. Well, we will see differences within these respective populations more so than we are looking at differences between these particular populations. So these three problems with race as a measurable value, think about them, especially as we are moving forward with this particular concept this week, which is human variation and why it exists. Thank you for watching, and we will see you next time.